The moon you look at tonight is shrinking. It is cracking. And right now, it is running on its own clock, one that isn't even synced to Earth's. Somewhere deep inside our own planet, there might still be a piece of the object that smashed into Earth and made the moon in the first place. Most people think they already know the moon. Full moon, half moon, the dark side, that's about it. But scientists have quietly been finding some genuinely strange things about our closest neighbor, and almost none of it ever makes it into a textbook. So stick with me for the next few minutes, because by the end of this video, you will know things about the moon that most adults have never heard in their entire lives. Here's something you were probably never taught in school. The moon is shrinking. Not falling apart, not exploding, just slowly getting smaller. Its inside is still cooling down from when it formed billions of years ago. And as it cools, it shrinks a little the same way a grape shrinks into a raisin. But here's the problem. A raisin's skin can wrinkle. The moon's outer shell is hard rock, and hard rock cannot wrinkle. So instead, it cracks and folds, pushing up giant cliffs called thrust faults, some of them taller than a 10-story building. Over hundreds of millions of years, the moon has shrunk by about 150 feet around its whole middle. That might sound small for something the size of a moon, but it's enough to shake the ground. And when it shakes, it really shakes. On Earth, an earthquake usually lasts a few seconds, maybe a couple of minutes. A moonquake can rattle on for hours. Earth has water and soft soil that soak up the shaking fast. The moon has none of that, so the vibrations just keep bouncing around inside dry, solid rock for way longer. Here's why this actually matters right now. NASA found that some of these cracks and the strongest moonquake ever recorded both sit near the moon's south pole in the exact same region where astronauts are planned to land for the Artemis missions. Scientists are now studying which landing spots are stable enough, because a moonquake there could trigger a landslide in loose, powdery ground with almost no warning. The moon looks frozen and dead from down here. It's actually alive with slow-motion cracking that we only found out about a few years ago. On Earth, wind and water are constantly at work. They pick up sand, rub it against other sand, and slowly wear every sharp edge smooth. That's why beach sand feels soft between your fingers. The moon has no wind, no water, no weather of any kind, ever. So when a tiny piece of space rock smashes into the surface, and this happens constantly, it shatters rock into jagged little glass shards, and nothing ever comes along to smooth them out. Moon dust stays sharp forever. Under a microscope, it looks less like sand and more like broken glass and fishhooks. This turned into a real problem for the Apollo astronauts. Moon dust clung to everything, ate through the seals on their spacesuits, and scratched their helmet visors within just a few moonwalks. One astronaut, Harrison Schmitt, breathed some in by accident and came down with what NASA jokingly called lunar hay fever, a real sneezing fit on the moon. But the strangest part is the smell. Every single Apollo crew that brought moon dust back into their cabin reported the exact same thing. It smelled like spent gunpowder, like a gun had just been fired. Different astronauts, different missions, years apart, same description. And here's the part nobody has fully explained. Once those moon rocks got back to labs on Earth, the smell was just gone. To this day, scientists don't know for certain what caused it in the first place. One more strange side effect of having no wind or water up there. Neil Armstrong's boot prints from 1969 are most likely still sitting exactly where he left them, and they could stay there for millions of years. You've probably heard people call it the dark side of the moon. That's not really true. Both sides get sunlight. They just take turns exactly like both sides of Earth do. The correct term is the far side, the side that never faces us. Here's the part almost nobody knows. The moon always shows us the same face because it's locked in step with Earth's gravity. But that lock isn't perfectly still. The moon's orbit wobbles a little, kind of like when you slowly turn your head side to side while talking to a friend. They don't see all the way around your head, but they do catch a little extra on each side that they wouldn't see if you held perfectly still. The moon does the same thing. Because of this wobble, called libration, We don't actually see exactly 50% of the moon from Earth. Over weeks and months, we get to peek around the edges just enough to see about 59% of its surface. That still leaves 41% of the moon that no human being has ever laid eyes on directly with their own eyes from Earth, not once in all of human history. The only reason we even have photos of the far side is that spacecraft had to fly around and take pictures for us. This one sounds like science fiction, but it's real. Time on the moon doesn't move at exactly the same speed as time on Earth. Gravity actually slows time down a tiny bit, and the moon has much weaker gravity than Earth. So a clock sitting on the moon runs slightly faster than an identical clock sitting on Earth. The difference is tiny, about 58 microseconds every single day. For comparison, a blink of your eye takes around 100,000 microseconds. So we're talking about a difference smaller than a fraction of a single blink. That sounds too small to matter, but in space, tiny timing errors turn into huge problems. If a spacecraft's clock is off by even a few microseconds, its navigation can be off by real distance, sometimes enough to miss a landing zone completely. Because of this, the White House directly ordered NASA to build a brand new time standard just for the moon, called Coordinated Lunar Time. Basically, the moon is getting its own official clock, separate from every clock on Earth, so that every country and every company sending missions there can stay perfectly in sync with each other. Somewhere in the next couple of years, the moon will officially run on its own time zone. Not because anyone lives there yet, but because we're finally sending enough spacecraft that it actually matters. This is the one that still gives scientists chills. About 4.5 billion years ago, when Earth was still young, a planet roughly the size of Mars slammed into it. Scientists nicknamed that planet Theia. That collision was so violent it blasted a huge amount of debris into space, and that debris eventually clumped together into the moon. This is the leading explanation for where our moon actually came from. But here's the question that bothered scientists for decades. Earth got hit by an entire planet. Where did the rest of that planet go? Deep inside Earth, near the very bottom of the mantle, sitting close to our planet's core, there are two enormous blobs of rock that behave strangely. They're each roughly twice the size of the moon one, sitting under the African continent and one under the Pacific Ocean. Scientists found them decades ago using earthquake data, but nobody could explain what they actually were. In 2023, a study suggested an answer. Those two mysterious blobs may actually be leftover pieces of Theia itself, the very planet that crashed into Earth and created our moon. In other words, part of the object that gave us the moon in the sky above us might still be sitting buried inside our own planet, roughly 1,500 miles beneath your feet right now as you're watching this. We are still walking on top of a piece of the collision that made our nights beautiful. That's 5 things about the moon that most people go their whole life without hearing. And honestly, we're probably going to learn even stranger stuff over the next few years, as NASA gets closer to actually landing astronauts back on it. If one of these surprised you, let me know which one in the comments. I read all of them. And if you want more videos like this every week, subscribing genuinely helps a small channel like this one grow. See you in the next one.